What we're going to look at now are some special linear transformations. Now, first of all, just looking at dilation and shear transformations. And then there are others as well, rotation and reflection, but we'll just look at these four to start with. Now you'll notice if you have your information sheet, this is our relevant part for matrices, and you've got here your dilation matrices and shear matrices, rotation and reflection matrices. Okay. Now, oh, and by the way, yes, they have the circle and ellipse, which is nice and handy. Okay, so anyway, our dilation and shear matrices. Let's have a look at the first one. We've got here in our regular transformation form, the transformation T, which transforms our point x, y to a, x and y. So you'll notice that the only thing that's occurred is we've multiplied our original x value by a. Okay, this is a dilation by a factor of a parallel to the x-axis. Now you'll know with our transformation that xy as a linear transformation is ax plus by and cx plus dy, where our x coordinate changes to ax plus by. In this case, we only multiply the x by a. Okay, nothing happens with the y here and adding to that. It's just a times x, and the y is unchanged, so it just stays as y, as you can see here. And so if we were to write that as a matrix, transformation matrix, we'd have it as A, 0, 0, 1. And that's what we have here. Okay, A, 0, 0, 1. So this first one is our dilation matrix, okay, by a factor of A parallel to the x-axis. The second one here is a dilation, that's shown here, of A parallel to the y-axis. Now I've written here as dy. Okay, so the x remains unchanged, and the only thing that's happened is the y is being multiplied by some factor. I've written it as d simply because when we look at our transformation here, we have ax plus by, cx plus dy. And so just to relate that to this is what's actually happening here. Okay, we've just got this d times y happening. And so that's why I've got the d there. But on the information sheet, it is simply a, written as a. We've just got that in all of them. So that's a dilation. That's, you remember, a dilation is a stretching. Okay, it's making it bigger. Whereas our next two relate to shear. Okay, our shear matrices, or what's actually happening to it is that if you have a look at our transformation here, x changes to x plus b times y. So the x part here is not multiplied by anything, but we take our original x and we add to it. We add some factor times y. Let's just, if you go have a look on your notes, the previous page just gives a little explanation about transformations, shear transformations. Visually, this is what's happening. Okay, it's turning it from a rectangle, if it were a rectangle to start with, from a rectangle into a parallelogram. In this shear transformation, all parts along a given line L, okay, in this case L would be along your x-axis, okay, where a y value is 0, okay, they remain fixed. Okay, while other points are shifted parallel to L by a distance proportional to their distance from L. Hence, this b times y. Okay, so the distance from L is the y value. Okay, and it's it's proportional to that because it's b times that value. Okay, just you may need to just think through that a few more times, but essentially, our x, we multiply x by 1, and then we add b times y. The y value remains unchanged, as you can see here. And so as a transformation matrix, we write it as 1b, 0, 1. And again, I've got it as b because our transformation matrix is written as ax plus by, cx plus dy. So it's just this b part here. X is not 0, it's just x times 1. The a value is 1. Okay, so this is a shear by a factor of b parallel to the x-axis. The other one is that where the shear is parallel to the y-axis. Okay, so our x values remain unchanged, but our y values are changed in such a way as it's a factor multiplied by x and added to y. Okay, and so that's not a 0 there, that's a c, right? That's just to relate this to c here. So it's 1, 0, c, 1. Okay, so if we have a look at our information sheet, again, it's using a, so it's 1 plus a times 1x times a, sorry, 1x plus a times y, and the y's remain the same. We're in our one that's parallel to the y-axis. The x's remain the same because it's 1x plus 0y, ax plus 1y. Okay, so these are our shear matrices. These are our dilation matrices. Alright, and we've got these ones here, 5 and 6 listed. These are a rotation matrix and reflection matrix. So what we have is a rotation here is an anti-clockwise rotation of theta radians. So whatever our angle is, that many radians about the origin. Okay, and this is how it works. X is multiplied by the cosine of the angle minus y times sine of the angle. And then for our y value, it's changed to x times the sine of the angle plus y times the cosine of the angle. Okay, so that's how the rotation works. That is essentially the formula, if you like. And so if we relate that to our transformation matrix, the a times x part, obviously a is cos theta, plus b times y, well our b in this case would be negative sine theta, hence the minus y sine theta. And then for our y values is c times x, so our c is sine theta, plus dy, and the d value is cos theta. And so that's given here as our rotation matrix. It's given here on our information sheet. Okay, just remember that's an anti-clockwise rotation. Okay, so an anti-clockwise rotation, obviously we are looking at going this way. So if we're rotating that is theta. Now what if it was a clockwise rotation? Okay, if it's a clockwise rotation, then the angle we use is negative. Okay, that's important to remember. So if you've got a question where it says a clockwise rotation of 45 degrees, then you need to put in there as your angle negative 45. Okay, so keep that in mind. Alright, so let's have a look. That's our rotation, and then we've got here our reflection matrix. A reflection is given by this formula. Okay, x times cos 2 theta plus y times sine 2 theta. So the a and b times x and y respectively, cos 2 theta and y sine 2 theta. And the cx plus dy, the c is sine 2 theta and the d is negative cos 2 theta. And so we can see that on our information sheet as well. Okay. Now I think what we'll do is we'll leave that video there, and we'll pick up on the next video some examples that use this. Okay, so we'll leave it there.